Okay, so you've got 40 newtons and you've got a solid hemisphere, so I need the formula sheet out to get these centres of mass, and a solid cylinder, which is much lighter material. It's 0.8, that'll be 0.8 there, and the rest of it's fairly clear. And the centre of mass lies inside the hemisphere and is 0.2, so G is about there. I've got to show H equals 1.2. So it's going to be a centres of mass question. So what objects I got? I've got the hemisphere, I've got the cylinder, and that's it. So that will then give me the total. I've got to put down the masses. Mass of the hemisphere is 40 newtons, so I don't need any G's coming in here. The cylinder is 5, and total of that is 45. And I just want to work out the Y coordinates. And I have to say I'm going to take this bit, and it says it's 3/8 of the radius, so it's 3/8 times by the radius, which is 0.8, and I'm going to take upwards to be positive, so that's going to be the y-axis. This can be minus because it's gone down as it's below. Cylinder, centre mass cylinder will be right here, which is h over 2, and the total, it tells me that is 0.2, and it's below O, so that'll be negative. And then I can do, it's just like averaging, so I got 40 on this bit here, that equals minus 0.3. And so now I've got 40 times by that negative 0.3 plus 5 times by h over 2 must equal 45 times by negative 0.2. If I work that out, that will give me h equals exactly 1.2 meters. 6 marks seems quite a lot for that as well. Anyhow, so we now worked out that G is 0.2 there, and I can put the forces onto here. The weight comes straight down, and the weight is 45 newtons. And I've got a tension, it's pulling across in here, so that'll be T. I've obviously got normal contact force, which goes at right angles to the surface because it's normal, and since it's a radius, that will actually go straight through O, and that will be R. And it says that it's a rough plane, so it's going to try and slip down, so I've got friction going up like so. And I've got some angles coming in there, so I want to put the angles, that's 30 degrees, so that's 30 degrees there. And it says that by taking moments about O, that's that point O here. So part 2, take moments about O, and that means the anti-clockwise moments will equal the clockwise moments. So what anti-clockwise moments? I'm taking about this point here. Anti-clockwise, well, R goes straight through it, so that won't have any effect. G also, the line of action of G goes straight through it. So the only two forces I've got are F and T. So first off, with to find the anti-clockwise will be T. As T, if I extend that back here, that's the distance we're talking about, and we've just worked it out, and that's 1.2. So we got T times by 1.2 equals, and then that'll be F times by the distance F is the perpendicular distance from O, and that's obviously is 0.8, and that will give me that F equals 1.5 T, and amazingly that gives me 4 marks. It's going quite well. And now finally, part 3, we've got to find another equation connecting T and F. Well, it's not going to be moments, it's got to be taking T and F, so I'm going to want to resolve in one way or the other. So I'm going to resolve, and I'm going to go parallel to the slope. And that way I've got what's going up the slope. I've got the whole of that F, so I've got F. Anything else going up the slope? Yep, I've got part of this. So if I dot this in here, that's 30 degrees. That would obviously be 30 degrees. And so if I put it in pink, I've got this component of the T's going straight up there. So that'll be plus T, and it's going to be cos 30. And that will equal, what else have I got? Change back to blue. I've got the component of the force, of the weight rather, which is there. So that'll be 45, and that'll be sine 30. And that is sine 30 is a half, so that'll be 22.5. So I've got here F plus, well, I'm putting decimals, 0.866 T. Yeah, the first one's F, not T. So F plus that. And if I call that 1 and that equation 2, I need to sub 1 into 2, and we've got F plus that, so that'll give me 1.5t plus my 0.866t equals 22.5, and that'll give me t equals 9.509618, which equals 9.5123 significant figures. And then I need to sub, that's t, sub into, well, I'm going to put it into equation 1, make it clearer, that's equation 1, and that will give me that f equals 1.5 times by 9.509, etc., and that will give me that f equals 14.2644, which equals 14.323 significant figures on their newtons. And that gets us 6 marks. That's going to be one of the easiest question 8s ever, and it's done.